I'm Pascal. I work for Chili Cream. And just to get a bit of a feeling for the room, how many backend developers do we have here? All right. How many front-end developers? All the others? All right. It's a bit more front-end devs. Anyway. Okay, so today, that's some weird colors. Today we'll talk about enterprise GraphQL. But first, let me introduce you to Chili Cream. That's a company that we founded a few years ago. We do a lot of open source stuff. We are known for our GraphQL server, Hot Chocolate. But for the ones which are actively observing the GraphQL ecosystem, they probably also heard about Fusion. This is a fully open source licensed, MIT licensed distributed GraphQL specification and server that can be used for things like federation. We also do tooling, which is not only for the .NET ecosystem. We'll see a bit of that later on. For example, where you can manage your gateway, where you can have insights about your GraphQL servers, and where you can also have open telemetry integrations, where you actually see deep inside of your GraphQL server and see the traces and have insights on the trace level. And what we also do is we work a lot with different enterprises. Enterprises of any size, of any scale, small companies, big companies, and we help them along on their journey with GraphQL. Now, in the past couple of years, we have seen a lot. And we have seen a lot of patterns that repeat itself. And today I want to present my view on how companies build GraphQL APIs. And we'll have a look at 3 patterns that we've seen that repeat throughout a lot of different companies. We'll start with database first, then we'll go into a GraphQL layering approach, and then we'll talk about enterprise apps in the end. Little disclaimer, there's no right or wrong. Whatever you do and works for you, go ahead with it. There is no recommendation what you should do and what you shouldn't. Use what works best for you, so why change it? Anyway, we'll start with database first. As the name suggests, the center of the database first approach is the database. And this database is exposed through a GraphQL API, so you access the database through the GraphQL API. When you write a query, it's translated into a SQL statement, executed on the server, and the data is returned. Many companies and many GraphQL tools do this. Take a database and expose it as a GraphQL schema. To name a few, there's Hasura, there's dgraph, there's Prisma, and also MongoDB Atlas. Although MongoDB Atlas is deprecated and Prisma doesn't use GraphQL anymore. So why is that? It turns out that just exposing your your database schema as a GraphQL server is not actually what you want for even the simplest of use cases, because what you want to do is you want also to have authorization, you want to have some business logic on it, you want the authentication, you want to reshape the graph, you may want to integrate another REST service, you name it. Now, companies like Azure and dgraph exist because they saw this and they changed their strategy and now also have these actions and extensions and whatever they call it this day. We honestly know this already. I mean, if you remember back in the days where we had big Oracle databases, with Oracle UIs and stuff like this, we knew that exposing a database as the application is probably not what we want. You see a person in front of you which has suffered a lot of pain with triggers. Turns out that database first wasn't actually GraphQL first in the first place. Now, there's even more tools that support this pattern. For example, PostgreSQL, which supports all of the things that are listed above. But there's also GraphQL servers, like, for example, Hot Chocolate, where this is supported by implementing resolvers. So why do enterprises use this approach? It's crazy how fast you can develop with it. And it's so fast, in fact, that we're going to do that with the Hot Chocolate server that doesn't exist at the moment. So we have a .NET project. Hot Chocolate is a .NET service, so I'm sorry. And that will take 30 seconds to implement a GraphQL server, I hope. So what we need is a query type. And we'll just add this. And then we need to return the product because we want to expose the product, right? Product, get products, there we go. Then we inject the database and we expose the products. Now we have a GraphQL server, we have a query type. What we need to do is we want to say that we want to also have pagination on it. We want to use projections on it, which basically project into the database. We project the GraphQL query into a SQL statement. We want to have filtering, which uses this rich where clause that you can use to filter, and we want to have sorting. Now what we need to do is we need to actually add the GraphQL server. We can do this by adding the GraphQL server. And we can actually just accept, no, we don't. Different key bindings. Let's say we add the query type to the GraphQL server. And then we say we add filtering. We add, oh, that's wrong. We add sorting. And we also add pagination. No, we add projections. There we go. And what we have to do is we have to expose it. Map, GraphQL. And now when we run this, we expose the database. We expose the database that should expose products in a GraphQL server. So let's hope this runs. There we go. Go over to BCP, which is banana cake pop. We talked about it. And this basically is a GraphQL ID where we now can write the query and we can access the products. And in the products, we can drill in. We can, for example, page through them and say we want to have a product we want to have the name of a product. Oh, sorry, still in Vim mode. And we want to have the brands of the products. And when we execute this, we get the data returned. So this is how easy it is to implement a service like this. Now, it's very easy to get going with this approach. And there's various tools to choose from, like we have seen. When I learned one thing in life, then it's nothing is for free. And so what are the problems that people have with these approaches? Well, there's a really close coupling between your GraphQL schema and the database schema. And you might not want to have this, because every time you make a change to the database schema, for example, renaming field, it will have an effect on the GraphQL API. You can work around this, but it's often really tedious to do. And because it's not the same language, the SQL language and the GraphQL SDL, it's very easy to expose stuff that is very SQL related. For example, a join table. And it's really hard to work around these things in these approaches because they're just facts that exist in the GraphQL, in the SQL database schema. Another thing which is really challenging is overexposing, especially when you have a public GraphQL API, but also when you have multiple consumers. It's very easy with this approach to expose too much information. It's good practice to follow you ain't gonna need it in an approach in GraphQL, where you only expose the data that people are going to, that developers are going to consume in the front end. Because every field that you introduce is a liability. You have to have the proper authorization on it, you have to have the change tracking on it, you can never remove it if someone uses it, and whatever. And with database first, it's just one flag. You say, I want to expose the products, and we have everything of the products exposed, and we actually have to filter out whatever we want to filter out. And the last thing is you are very limited in flexibility, which means that some things are weird that you have to do to map a GraphQL schema into a database schema into a GraphQL schema, just because it's not the same thing. And if you do it, some things will feel weird. And we see a lot of companies starting with this approach and then later realizing down the line that they actually want to have more control over what to expose, how to expose, where to put the authorization, and where to put the business logic. So they outgrow this pattern throughout their GraphQL journey. And they start using another pattern. While GraphQL can be used to very easily expose your database, GraphQL has much more potential, because as the database is a central part to many of the enterprises, an enterprise is more. And GraphQL is a tool that allows you to expose the business through an API. So not just the database, like the whole business, the core domain. And we can do this with the GraphQL layering approach, where instead of calling the GraphQL layer directly calling the database, we put the business layering in between. And when we have this business layer, the GraphQL calls the business layer. The business layer then does the database calls, and there's where we can have the business logic. Now, in a bit more advanced version of this, the business layer doesn't access the database directly. It uses GraphQL data loaders to actually load the data, which then is used for doing, which is much better for performance because you have already cached data in there. And it only accesses the database directly when you use mutations. So in this example, GraphQL is only a thin layer across an existing business layer. For example, when we have a look at this service, completely different service, that exposes a chat API, we see that we have a service layer. And in the service layer, we have business concerns. For example, what do we have to do when we create the chat, right? We have to check if the user is logged in. If the user is not logged in, we throw an exception. Or when we get a chat by ID, we check if the user is logged in, and then we load the chat over the data loader, and then we check if it's the chat of the user, because only users that created the chat can access the chat, and other users cannot, to prevent leaking information. And this is the business of this subscription service. And the GraphQL layer is actually quite tiny. The only thing that we do, for example, in queries, is we inject the service, and we call from the GraphQL layer the service layer. And we do the same thing on mutations as well, and also on subscription, but that's another topic. So if we go back, the benefits of this approach are quite clear. So you have your business in isolation, which means you can test it, you can reuse it. One thing that we haven't had a look at is actually here. When we look at the query, we see, or let's go in one extension. So this is a type extension. We see that we have a method on this service which is named getMessageById. And when we look at it, we see that this loads a message by the message ID. Now, we do all the authorization check, all the business concerns in this method. And it's actually used in two different types, where a type has a message ID, and we want to basically create the message object in this type with the resolver. So we can reuse stuff, which is great. And it's a lot more flexible, as you are in control. You do not have a database exposed. A change in the database does not necessarily have an effect on your GraphQL schema. And it scales. The cost of adding a feature will stay more or less the same, right? While the performance also stays more or less the same, because it just vertically scales. It could be a problem in organization sizes, but the project itself, as it grows, the more types you have, the architecture will just scale a lot better. And this is a bit of a hot take, because I personally think that this will lead to better GraphQL schemas, not because separation will magically produce better schemas, but because people that do this care about the schema and not just expose it, right? So people that tend to do this, they have this developer love for handcrafted things that they actually care about. Now, what are the problems of this approach? Well, the first point is obvious. It's another layer of complexity. Iteration speed will be slower initially, but when your project grows, it will be actually probably faster than when you just expose a database. But it's an inherent slowdown. And then the next problem is it's harder to optimize, which means that when you project directly from the GraphQL API into a SQL statement, you know that the name of the user is selected. But when you do this in the business layer should actually not even know that GraphQL is calling them. So how do you tell the business layer that the name is selected on the GraphQL API without letting them know that the GraphQL API calls the business layer? So it's a bit harder to optimize. And this pattern is something I recommend to a lot of people, because it's easy to do, it's simple to use, and it scales well. But companies, especially big companies, sometimes use a different strategy. And these are in the enterprise space. So let's talk about enterprise apps. And let's begin by asking, what is an enterprise app? So by the definition of Gartner, an enterprise app runs in all phases of the enterprise, which means it integrates into the core business domains, like sales, accounting, finances, and human resources. A business is more than just one pillar. It's actually built on different business units. For example, you see that there is sales, there is an inventory service, there is an accounting service, and all of these together create this enterprise. When an enterprise grows, it will have multiple of these business units. For example, B2B, B2C, or asset management. And these business units together are one big enterprise. For example, a big insurance company, where you have private customers, you have public customers, whatever. 20 years ago, digitalization struck, and you had to create an application which takes this domain and covers it all the different things of it. And how do you model something like this that handles the complexity of such a system? And how do you build this into software? Well, enterprises have tools that they use, tools like CQRS or domain-driven design. And with these tools, they can model these very complex domains into something which is actually buildable as a system. And we'll have a look at these unrelated to GraphQL quickly. For example, CQRS. CQRS is Common Query Responsibility Segregation. And what it does is, it separates read and write models. Because read and write models have completely different performance characteristics. You want to read often, you want to write less often. So you can optimize for reads in certain cases, where you can also do caching, and you can optimize for writes when you, for example, need some scoping, or you need to aggregate data or whatever, where you have completely different requirements. A mutation can take longer when the user buys something and does the checkout. This is an action that can take longer than when you just fetch data. And it reduces the complexity in data handling, because you can use this scoping approach like we do in .NET with unit of work. Good. So the commands in CQRS are task-based interactions, like, for example, a checkout, where you pass in the user ID, the cart items, and then the checkout process happens. That's one command. The queries, on the other hand, are is when data is written, so it's a read model. It's purely informational, no side effects, nothing is changed. And this was CQRS. Now, when we have a look at the other approach that we want to talk about today, is domain-driven design. And the core principle of domain-driven design are these two things. It's a ubiquitous language and a model-driven design. The ubiquitous language describes a language that is spoken between developers and stakeholders. And this is something which is really, really important, because developers and stakeholders, the business team, are two different teams. And these two different teams, they often don't speak with each other. So the business guys come with a drawing with a button on it and say, we want this button. But they have no idea how the process actually works. Their requirement is to have this button. And when the developers then try to implement it, they realize that it doesn't fit the system that they built, because they talk about completely different things. Because in the first place, they implemented the wrong application, because they talk about different things. In domain-driven design, the system is built together with the stakeholder. So developers and the stakeholders together design the system. They design a model which is an abstraction of the real world. And this system is based on the model of the domain, which describes the business. It simplifies this complex system and gives an overview. And what's very important is it allows for emulation. So when you have a model, you can think about something, and then you can try it in the model and try it out before actually implementing it, which is fantastic. Good. The building blocks of DDD are entities, value objects, aggregates, and repositories. So entities are identifiable by ID. Value objects are just structs where you have, for example, an address which isn't identifiable by ID. We have aggregates, which we'll have a look at, and repositories which load and save the aggregates. Good. An aggregate is a group of classes, enums, and value objects that are related to each other. It starts with an aggregate root, which is usually an entity like order, which is identifiable by ID. And the order has order items, which are just some classes which have data in it, which are not identifiable by ID. And there's also an enum, for example, order status, and so on. In DDD, there's a concept of a bounded context, where a bounded context is a group of aggregates that belong together. So stay with me for a second. It will make a lot of sense soon. And this bounded in an application, there can be more than one bounded context, and an aggregate can also be across different bounded contexts. For example, here, where you have a user in the ordering service and a user in the identity service. Now, an aggregate only knows itself. So when you do a change in the order aggregate, you cannot do a change in the user aggregate. You can only do a change in the aggregate you're working on. It's the reason why there's domain events, which trigger side effects in other aggregates. And there are integration events, which trigger side effects in other bounded contexts. Good. So what are the benefits of this approach? The benefits are that you have a perfect alignment between software development and business needs. It's very flexible. You can scale this until any scale, and it's decoupling the components so that you can grow with different teams. The problems is it's complex, it's time-consuming also to talk about, and you need to have a team of skilled experts. You need to have a team of skilled domain experts, which is actually something that you probably want in bigger enterprises, because someone needs to know how the business works. So if you combine these, then you have a very clear understanding of your domain, you scale to any organization size, and you have a very clear path from a business ID to a product. Now, the problems are, it's very complex, as you see. It's a huge commitment to do, because you're not only changing the developers, you're changing how the business works. And it's a massive cost if you want to do this, because you have a lot of overhead. So why should you use this? And how do you solve the problems that you have identified here with the complexity and such? Well, we do solve this how we solve all our problems, and we just throw GraphQL at it. And we then look at with the GraphQL lens, and we see that the commands are actually nothing else than just mutations. The queries are nothing else than just queries. The ubiquitous language, well, we have a ubiquitous language. We have that. It's the schema. And the schema is actually something that a lot of people which work in companies, which work with a lot of companies, tell you. You have to do schema planning meetings, and you have to include the stakeholders. If it's only developers, and even worse, if it's only front-end developers or only back-end developers, the schema will never work. You have to have front-end devs, you have to have back-end devs, and you also have to have someone which actually knows how the business works in this meeting. And then you can plan it. It's actually good to think before you do in enterprise apps. Now, the building blocks of entities, of DDD. An entity is a node. A value object is a scalar. An aggregate is a type. And repositories are just the root types, the queries, the mutations, where you have get user by ID. It's where you load the data from the database. And the bounded contexts are actually just different subgraphs. And you put something like Fusion in front of it that composes these different subgraphs. And the beauty of it is that depending on, it doesn't matter how these subgraphs are implemented. It could be that you use the GraphQL layering approach for the product graph because it's a bit more complicated. But you can use the GraphQL first approach in the user graph because it's just a database that you want to expose. And you can use complex patterns like clean architecture with CQRS and whatnot in the order subgraph, where you do the ordering with the events and stuff. So my hot take today is that the only way to make enterprise apps accessible is through GraphQL. And we do this in the workshop that we have, where I swear that I will probably not nearly collapse on stage. And we build together this application. And what we do in this application is we build a web shop with ordering, with filtering, with all the GraphQL patterns that you can use. And we do this in a way that is federated. So what we do is we build something like, where's Banana Cake Pop? We build something like this, where you have a gateway with multiple clients and with a lot of subgraphs. And this is what we do in this GraphQL workshop. And we do this in a fashion where you have the complex patterns at the end of the workshop. We have the easy patterns here. And if I have more time, I would actually show you some of the more interesting topics in this domain-driven design approach. But I'm unfortunately out of time. And that's where I will stop today. If you want to learn more, you can either reach out to us on our website, or you can just scan the links, and then there you will see the next workshops we have. Thank you.